And we're back. All right, today we're going to talk about the different types of chemical reactions, of which there are 5. Okay, there's synthesis, combustion, decomposition, single replacement, and double replacement. So the first one, synthesis, if you think about the word synthesis, you are combining two different things to create one thing. So in the case of chemistry, you're combining two or more substances, whether they be elements or compounds, to produce one product. So a giveaway of a synthesis reaction is if you see one product. And when we write chemical equations, if we have two or more reactants or products, we separate them by a plus sign. Okay. Then, instead of math, where you might have an equal sign to separate the reactants, which are on the left side of the arrow, from the products, which are on the right side of the arrow, instead of an equal sign, we use an arrow. So a common example of a synthesis reaction is the combination of sodium and chlorine gas to produce sodium chloride, which is salt. So the giveaway for this synthesis reaction is the fact that there is just one product. Okay, now the opposite of that, the reverse of a synthesis reaction, is a decomposition reaction. So if you think about the word decomposition, it's one thing breaking down into two or more things. In the case of chemistry, a single compound, and it has to be a compound, will break into either two or more new compounds or elements. And in order for a compound to decompose, it doesn't just decompose on its own. It requires some sort of heat or light or electricity in order to occur. Okay, so the general form, you have one thing, AB, a compound, breaking apart into two or more new elements or compounds. Okay, so an example of that is NaN3 will break down into its constituent, or two different elements. So it will break down into sodium and nitrogen gas. All right, now the third type, a combustion reaction, you are combining oxygen with another substance. So a giveaway for a combustion reaction is that oxygen by itself, O2, as a gas, has to be a reactant in order for it to be a combustion reaction. So in this example here, hydrogen gas is reacting with oxygen gas to produce water. And so in general, for a combustion reaction, you have one thing reacting with oxygen to produce the oxide of that element. However, another type of common combustion reaction is it reacting with a hydrocarbon. So something containing both carbon and hydrogen. So for the general way how we do this, so CXHY, those could be any numbers. If a hydrocarbon reacts with oxygen, automatically what will be produced is carbon dioxide and water. So for example, if we have methane gas, it's a hydrocarbon because it just contains carbon and hydrogen. It will produce carbon dioxide and water. And that is the case for any hydrocarbon, a compound containing carbon and hydrogen. So anytime you see oxygen, O2, as a reactant, it has to be a combustion reaction. And one thing I want to add to this reaction right here Yes, it is a combustion reaction because oxygen O2 is a reactant, but this reaction could also be a synthesis reaction because there is also one product. So if you classified it as a combustion reaction or as a synthesis reaction, both would be correct. Okay, now the next type involve both an element and a compound. So what happens, this is called a single replacement reaction, so named because the element that's by itself in the reactants replaces one of the elements that's in the compound in the reactants, and they essentially switch places. So now in the product side, the A and the B switch places, so A is now with X and B is on its own. So an example of that is the reaction we did in the lab. Okay, remember we reacted a magnesium ribbon with hydrochloric acid, and we produced magnesium chloride, solid product at the bottom of your evaporating dish, and we produced hydrogen gas. Okay, so a single replacement reaction, you always have an element, in this case magnesium, reacting with a compound to produce a new compound and a new element. Okay, so that's a giveaway for a single replacement reaction. The last type is similar to single replacement, but now it's double replacement. So now instead of an element reacting with a compound, it is a reaction between two different compounds. Okay. So this is the general form, and the reason why it's called double replacement is those two elements are replacing each other. Okay, and this is the general example. CaOH2 and HCl are both compounds, and it produces two new compounds. So you'll see the C and the H switch. So now the Ca is with the Cl2, and the H replaces the Ca to produce HOH or H2O. All right, that's it for today. See you next time.